Well, let me continue with some other aspect of earth pressure. We have Rankine's Coulomb, we have discussed vertical wall, inclined wall, vertical level backfill, inclined backfill, all those things we have considered, how to use them, that we have discussed. And everywhere one thing we have considered so far is the granular backfill, and it is known that granular backfill is advantageous because it is a good draining properties it has it. So, if there is a water, it can drain quickly and pressure on the wall will be reduced in that way, but sometime maybe backfill may be used with some soil which may have some amount of cohesion. So, we need to see how this pressure can be calculated when the soil possessing C and phi both. So far our consideration was, or consideration restricted to granular soil only. Now, it is with some amount of cohesion, that means C phi soil. So, let me see that the first slide here. You can see that this is the suppose backfill and this is the wall, and we are considering a vertical wall for the time being, and you can see that at any point that sigma 1 and sigma 3, and if it is C phi soil, then of course your shear strength envelope will be the equation will be A is equal to C plus sigma tan phi, and this will be in the shear strength axis, it will act somewhere, it will intersect somewhere here, and it will be tangential to the Mohr circle at failure. So, Mohr circle, this is the sigma 1, and suppose this is active case I am considering, this is sigma 1, at the fully active condition when it achieved, this is sigma 3. So, based on this Mohr circle is drawn, this Mohr circle again is expected to the tangential to the failure envelope, which is so far whatever we have discussed, the failure envelope passing through the origin or axis, but here actually it is not passing through it is intersecting the shear strength axis. And now this angle obviously has to be phi, and if it is so, geometrically this portion will be C cot phi, okay, and again this portion will be definitely sigma 1 plus sigma 3 by 2, and this radius will be sigma 1 minus sigma 3 by 2. So, these are the things if it is known, then using the geometry again the way we have done active case for phi soil, similarly we use this triangle. Now, we use this triangle, and from the geometry we can see that relationship between sigma 1 and sigma 3. So, if I go that way, so let me see the next slide. You see that so sin phi I have expressed in sin phi will be radius divided by this distance. So, this distance will be, I will go back, sin phi will be nothing but this by this, and this is actually radius, and this is actually this plus this. So, this is the thing is done there also. This is the thing done there also. You can see this is radius first, and this is the radius, and this is the from the 0 to center of the circle, and plus from the 0 origin to the vertex of the triangle C cot phi. So, this will be there. So, if I little simplification if I do, then it will be sigma 1 minus sigma 3 divided by sigma 1 plus sigma 3 plus 2 C cot phi. So, we are getting this expression, and this is sin phi in terms of expression. So, I have to express sigma 3 in terms of other parameter like C, phi and sigma 1. So, if I this one several steps if I do and simplify, it will reduce to this, form. the sigma 3 will be equal to sigma 1 into 1 minus sin phi by 1 plus sin phi minus 2c under root 1 minus sin phi by 1 plus phi. So, we can see this is actually nothing but as per Rankine Ka, and this is actually this portion is nothing but root Ka. So, I can write sigma 1 Ka minus 2c root Ka. That means, if I consider now a ground surface here, and when your depth is 0, h equal to 0. So, sigma 1 will be equal to gamma times h, so when gamma is 0, when h is equal to 0, then you can see that sigma 1 will become 0, that means this portion will be 0, that means sigma 3 will have a negative value. So, that value is suppose this negative value is there, and then with the increase of the h, the value will be again this plus and minus will be, when they will be equal, they will become sometimes 0, and then this plus value become big, then it will become positive at some depth. So, the pressure diagram for earth pressure diagram for C5 soil, this is minus, and this will be like this. So, this is the only difference. The Ka expression is same, only because of the C we can see that pressure diagram is changing, and when depth equal to 0, there is a negative pressure at the surface, and that negative pressure means what? It creates tension in the soil, and so that is actually minus 2c root Ka, and with the increase of h, the value become negative value decreases, and sometimes it becomes 0, and then finally it becomes positive. This is the value at the bottom of the suppose wall. Now, now we can find out what is the thrust. Sometime we can this much minus get cancelled. So, this will be the only thrust. This is the pressure only acting as thrust. Sometime to make safer, we ignore the minus part, only we consider the area of this, and that we consider as a thrust. Either way it can be done. So, this is one part I will just show. Next I will go to the passive case. You can see passive case. Passive case again it will be same sin phi, and we will change. Let me go back once again. Let me go. So, this become actually this becomes sigma when it is a passive case. This is the original, and then it is final. Okay, so this is the only thing. So, otherwise everything change. So, this becomes sigma 3, this becomes sigma 1. That is the only change. So, this change if I do accordingly, if I ultimately this by this is sin phi. So, if I do that, so passive case, your expression for sin phi will be sigma 1 minus sigma 3 by sigma 3 plus sigma 1 2c cot phi. Sigma 3 is a bigger there actually. So, this way if I write, and now of course, if I express sigma 3 in terms of sigma 1, then I get this expression. I get this expression, that means what? Sigma 3 equal to sigma 1 plus psi phi by 1 minus sin phi plus 2c under root 1 plus sin phi by 1 minus sin phi. This is nothing but Kp, this is nothing but root Kp. So, I can write sigma 1 Kp plus 2c root Kp. So, if there is a ground here, okay, and see if I want to find out the pressure diagram. So, sigma 1 is nothing but gamma times h. So, at when h equal to 0, this component becomes 0, but this component will be there. So, because of that there will be a positive value at this point, which will be equal to 2c root Kp, and this is suppose okay, this is the wall face and this is the value, and from this value further when H is increasing, so this will be adding. So that means from here it will be sloped. So diagram will be something like this. When it is a passive case, then earth pressure diagram will be some positive value at the surface and again some positive value at the bottom. This is a trapezoidal diagram, and to find out the total thrust on the wall, we can find out the area of this diagram. So, to find out the area of this diagram, I can make a triangle and a rectangle, or you can know the area of the trapezoidal base, the formula and centroid, that also can be used. Otherwise, this is the area of this diagram is the thrust which will be acting somewhere there. So, this is actually some extension of Rankine's and Coulomb's theory, when there is a some amount of C is present with the soil. So, what is the active? So, because of the presence of C, your earth pressure coefficient either in active or passive case is not changing. Soil possessing both C and phi, based on phi we find out Ka or Kp. So, the same thing will be there. And now, while finding out the this sigma 3 is nothing but, here actually it is nothing but Pp, passive pressure intensity, and so we are getting the Pp in terms of this sigma 1, Kp and C. Okay. So, this is the way we have to do, and similarly whatever we have got there, active case we have got sigma 3 equal to sigma 1 Ka minus 2 C root Ka. There also you can see this sigma 3 is nothing but Pa, active pressure intensity, which is with respect to vertical pressure intensity, cohesion and active earth pressure coefficient. So, these three things, the two things also I have just maybe highlighted in addition to the granular soil. Next, let us see the once again together active and passive, how is the pressure diagram I will show again. So, you can see here the soil cohesive backfill and with having C and phi and sigma 1 and sigma 3 like that, because of the wall movement in this direction or this direction. So, it moves this direction, this is the active case, and your pressure diagram will be something like this. At this point 2 C root Ka, and at this point gamma H Ka minus 2 C root Ka. And when it is wall moves this direction, then your pressure diagram where will be 2 C root Kp, and at this point will be gamma H Kp plus 2 C root Kp. So, these two things to be remembered, and to find out the thrust you can ignore this portion, take this triangular area, find out the area diagram and act as 1/3 of this, not entire height of the wall. You have to find out where it is 0 from there. So, if it is h naught at a height, it is becoming 0 h naught. So, this will be h minus h naught will be the height, this is the height divided by 3 the point of application, whereas for this the point of application you have to find out. You can divide into two part, rectangular part will be at the midpoint, triangular point will be at h by 3 times, then resultant point of application can be obtained by taking moment. Okay. So, this is the diagram you have to understand. Sometime without calculation also, if you do not know the value of C, phi, anything, but if it is asked to find out the active pressure diagram, passive pressure diagram for a C phi soil, this is the diagram you have to show in terms of those parameters, no need to have values. Now, you can see, as I have mentioned, that when this is active case, you will have negative pressure, negative lateral pressure. Negative lateral pressure means what? It is a tension. When there is tension, then means soil actually will have cracks. So, this is the way it can crack actually for C phi soil. So, we can find out what is the depth at which tension will create. So, what is the basis actually you consider? That means the crack will reach up to a point where your pressure is 0, neither plus nor minus. So, you have the expression gamma h k minus 2c root k, this is the expression. So, at this point if I equate to 0, that means how to find out depth of tension crack? We assume that at a depth where tension crack will reach or will not go beyond that, that is the point where actually pressure is 0. So, if I set equal to 0, from there we will get H equal to H t, which I will show the next slide. So, H t will be there will be some expression we will get finally. Okay. And you can see now unsupported cut, that is what our ultimate aim, up to what depth tension crack will go. In some area it is useful, some calculation it will be useful, but in many a times when we do excavation, suppose there is a soil and we have to excavate quite deep, okay. And this excavation, obviously if you know the soil is sandy, then we cannot do without support any excavation, because as soon as we cut, the soil will flow and come to the excavated portion. But if the soil is possessing some amount of phi, generally it can vertically you can cut up to some depth. Okay. So, that some depth is what, that we have to find out. So, for that you can see that we have already expressed sigma 3, or it is actually you can say P A equal to sigma 1, or this expression we have got. At a ground surface H equal to 0, sigma 3 become this and tension, that negative pressure is started from a surface, and this negative pressure will go up to some depth also. The theoretical depth of the crack at H t can be determined by recognize that at the bottom of the crack sigma 3 is 0. Suppose the crack is formed something like this way cracks are formed. So, at this point at least your sigma 3 is 0, or sigma 3 or P A, intensity of active pressure is 0. So, if I assume that, then I can write this expression 0 equal to gamma H t K A minus 2 C K A. So, if I simplify this, then your H t become 2 C by gamma root K A. But this is not the actual unsupported cut depth. Since your pressure diagram is something like this, already I have mentioned, is something like this. So, this is negative pressure, and that means to balance this negative pressure, another similar depth actually can go. So, ultimately in fact twice of this H t, this is if this is H t, twice of H t we can excavate without any support. So, that means depth of unsupported cut, depth of unsupported cut will be equal to twice H t equal to 4 C by gamma root K A. Okay. And if it is purely cohesive soil, if the purely cohesive soil, then this unsupported cut will be 4 C by gamma. And you can see now, if it is a C value of a soil is 100 kPa, C value of a soil is 100 kPa, and then 4 C by 4 into 100 divided by gamma, suppose 18 kilonewton per meter cube, or suppose I take, for the simplicity I take 20. If I take 20, then this gives you 5, I mean 20 meter. That means if a soil is having only C, which is having 100 value kPa and no phi, that soil theoretically actually almost 20 meter we can vertically cut without any support. Okay. So, this is the one. Similarly, we have got the expression for P A and P P for purely you can say granular soil and C5 soil, but if you have only if you have only a C soil, then what will be the value of earth pressure? That also you can find out when phi equal to 0, K equal to what 1, is it not? So this value directly gamma into H will be there minus 2C. So that also we can modify when there is a no friction is there in the soil, purely cohesive soil. Then also for that, how to find out the pressure? Only Ka become 1, Kp become 1, and corresponding this expression will be remain unchanged. Only thing Ka Kp value will be 1, and this is the generalized expression for unsupported depth of cut equal to 4C by gamma root Ka, and if the soil is purely cohesive without any friction, then the expression modified to 4C by gamma, because root Ka, when Ka actually become 1 when phi equals 0. So 4C by gamma, and taking 100 as the as a cohesion value, and then we can see that at a site where only purely cohesive soil is present with a C value of 100, then we can have an excavation up to 20 meter without any support. Next, you can see now there is one more part. We have only considered so far only the backfill. Sometime on the backfill also, what the backfill, there may be probably some equipment may be there for some work, or some other reason, some loading may be there. So if there is a constant loading over the surcharge in the form of surcharge is there, how to find out the pressure diagram? So this pressure diagram we can assume this Q surcharge can be imagined as, suppose we can take Q equal to suppose gamma H, assume gamma equal to soil gamma, then H equal to Q by gamma. We can imagine here the wall is not here, its wall is somewhere here, additional H is there, this actual height of the wall is here, but another wall above that is there, small h, which is equal to Q by gamma, and if I draw the pressure diagram from here, it will be reaching to this value. This is the way one can visualize. Then if I consider the wall started from here, then because of this weight of this soil at this point, what is the pressure? This is the pressure. So that pressure will be constant, and because of this soil, again there will be additional pressure. That is the way actually you have to do. This is the philosophy. So if I consider this way, then you can see at any point you will have sigma 1 will be gamma H plus Q will be there. I can consider this is the pressure, and then because of this soil, again pressure is increasing like this. So in that case, what will happen? This pressure is there, that is Q plus this. So this is gamma H plus Q. So this is gamma H, this one plus Q. And similarly, if it is C5 soil, then it is gamma H plus Q tan square 45 minus Q, but 2C tan this one. So sigma 1 this one, and sigma 3 this one. This way can be. This is of course the generalized C5 soil is considered, and based on that both the expression is given. So that means if there is a if there is not C5 soil also, if there is a surcharge is there, so what you have to do, if there is a wall here and surcharge is there, then pressure diagram will be will have because of this surcharge, there is a diagram which will be equal to Q times Ka, and then because of the soil, this will be also Ka times gamma into H. these two together will be the pressure. So, that means you have to find out pressure will be at this point will be Q plus weight of the soil, and that has to be multiplied by the coefficient of earth pressure. Similarly, if it is a passive, the same Kp will be multiplied. So, if you take this, accept this philosophy, then I can show you the next slide. You can see corresponding to this, you can see because of the soil pressure from here, this is the diagram. So, sigma 1, which is actually you can say gamma a gamma into H into Ka, and this is the diagram as I have assumed that height, this is actually height, because of this height it become pressure this much. So, if this is the pressure is constantly acting, so this sigma 2, suppose Q was acting, so sigma 2 will be Q into Ka, and then your total diagram will be sigma 1 plus sigma 2 here, sigma 1 plus sigma 2, and here also will be sorry, sigma 1 plus sigma 2 will be here, it is sigma 1 I have written, sigma 1 plus sigma 2, and here also whatever value will be there, this 0 will be there, and here it will be Q into Ka, this will be Q into Ka, this will be Q into Ka will be this value, and here actually sigma 1 and sigma 2, that under that sigma 2 is this one and sigma 1 is this one. So, that means if there is a surcharge also, you can just forget about the surcharge, whatever the normal loading is there, you find out the pressure diagram. Additionally, because of the surcharge, if there is a Q intensity of load on the surface backfill is there, then simply you multiply by Ka or Kp depending upon whether it is active or passive, and that pressure you keep constant throughout the depth, and then find out the area of the all the diagrams, and that will be the total active thrust or total passive thrust. And to find out the point of application, obviously you have to find out the individual point of application here, individual point of application here, and then resultant point of application here. So, that by taking the moment, considering the moment equilibrium, we can do this. So, I actually by this I have almost completed various aspect of the earth pressure calculation which is required undergraduate level. Only thing is I need to now take a problem. I have mentioned that you can calculate this way that way, but until unless you do, what are the difficulties you will not understand. So, I will take a number of problems, maybe in 6-7 problems I will take, maybe more than 1 hour or 1.5 hour I will spend on solving problem, different types of problem, level backfill, inclined backfill, layered backfill, then C5 soil, all those combination, and only granular backfill and C5 backfill together, all combination with surcharge, without surcharge, all those combination I will take some problem and try to show the solution procedure. Solution here is what? You have to find out active pressure diagram or passive pressure diagram, finally active thrust, which is nothing but the area of the diagram, and then find out the point of application of the thrust. So, those things I will take in several 2-3 session. I will take quite a good number of problem to show the application of whatever we have discussed in last 5-6 sessions. Thank you.